So today we're going to talk about a ship called SS Richard Montgomery. And some of you may know about the ship, but for the benefit of the room, this is a World War II American cargo ship that sank in August of 1944. And the crazy thing about this ship is that it contains about 1,400 tons of explosives. So there is the ship on the right. And the crazy thing is, it's currently situated in Thames Estuary near Kent. And from the image, you can see that's London over there, very close to London. And on average, the wreckage is at 15 meters deep, which means it can actually be seen from the surface as well. So, should we be scared about this? Sounds scary, right? So, are we safe? Most people agree that if this ship was to blow up, it would be the largest non nuclear explosion in history. There have been a lot of different attempts to try to have different solutions, but the discussion is that if anyone attempts to go on board to try to, detonate some of the bombs or try different approaches, this could actually be extremely fatal. So, what's the solution? Let's not touch it. Let's just let it be there. So, I want to tie this back to software engineering, right? And I want to read a comment over here which says, "Dear maintainer, once you're trying to optimize this routine and you have realized what a terrible mistake that was, please increment the following counter as a warning to the next guy. Total hours wasted here 73." So, similar to the doomsday ship that is just waiting over there, our code base has a lot of different bugs in it that one day could just explode. And there are a lot of different people that spend countless times optimizing different complex systems, right? Just like people trying to solve the issue with the ship. But the main issue starts with that this whole situation is extremely complex. And I want to take this opportunity to reference one of the books that I was reading that I found extremely useful called A Philosophy of Software Design by John Ousterhout. And this talks about the fundamental issue of software development, which is complexity and how to manage that essentially. And it's inevitable that when software grows large, complexity is going to happen in the software, right? You have new functions, new requirements, different programmers working on it, but how do you actually contain it? So there are two key takeaways for me from this. One of them was if you can figure out what the complex parts are of your system and understand and isolate them in a way that you don't actually change them a lot, you can make sure that it's hidden away. It's abstracted away in the sense that programmers, developers, testers, they don't need to interact with that a lot. The other key takeaway for me from this book so far has been this concept of tactical versus strategic programming. And essentially, what it means is if a programmer is a tactical programmer, it means someone who's extremely quick at creating code. So they're very quick at understanding the requirements and simply making sure you can churn out as much code as you can. But an issue with this happens where you try to think, it's just a small edge case. Maybe I'll introduce one or two small dependencies. I'll refactor someone in the future. But the issue happens, it's very hard to turn back once you start going this tactical path. On the other hand, you have strategic programmers, right? So these are the people who, before jumping into any project, they really think into understanding how to create software designs that is sustainable for the future. And this can either be proactive. So, when you have a project upfront, you can really nail down the design spec, or it can be reactive. So when new issues come in, rather than having simple patches, you actually make sure you can create sustainable practices and, make sure that the design is and the software is very sustainable for the future as well. So lastly, I just want to sort of tie this back with one of the talks given by Judah as well. And I was in her sustainable talk yesterday. And I think this ties it back well with sustainability because we need to realize that as developers, right, we're not just by creating inefficient, complex systems, we don't just waste our time, the time of other developers, but also it has a detrimental effect on the environment as well. So I think this is some of the key takeaways I took from this book and some of the talks I attended with this as well. And yep, that's me. Thank you.